Today I want to show you the awesome redox reaction between potassium permanganate and hydrogen peroxide. Check this out. For this experiment, we're using 200 milliliters of distilled water, a 500 milliliter beaker. This is potassium permanganate, 18 molar sulfuric acid, and this is 35% hydrogen peroxide. Start by measuring out 50 milligrams of potassium permanganate. Next, add the 50 milligrams of potassium permanganate to 200 milliliters of distilled water. Then add 400 milliliters of 35% hydrogen peroxide to a 500 milliliter beaker. Then add a drop of 18 molar sulfuric acid to your hydrogen peroxide. Once your solution of potassium permanganate is aqueous, start adding small amounts to your hydrogen peroxide, and you'll notice that something happens to the color. Check it out. Watch what happens. It's as though the color vanishes. What's happening here is the manganate ion in potassium permanganate is being reduced. So at this point, I poured the rest of the solution into the hydrogen peroxide, and it's very pink. But in just a few seconds, while it starts gaining electrons, that manganate ion is reduced from a +7 oxidation state all the way down to a +2 oxidation state. And that's because we acidified the solution of hydrogen peroxide with the sulfuric acid, and it slowly becomes clear. At this point, you can't see that pink coloring at all. It just becomes a clear solution. Just amazing. Here's the balanced equation for this amazing redox reaction. We start with the reactants potassium permanganate, hydrogen peroxide, and sulfuric acid. We have 2 moles of potassium permanganate, that's the 2KMnO4. We have 5 moles of hydrogen peroxide, that's the 5H2O2. And we have 3 moles of sulfuric acid, that's the 3H2SO4. When those combine, we get the products manganese sulfate, potassium sulfate, water, and oxygen. We have 2 moles of manganese sulfate, that's the 2MnSO4. We have 1 mole of potassium sulfate, that's the K2SO4. We have 8 moles of water, that's the 8H2O, and we have 5 moles of the diatomic molecule of oxygen, that's the 5O2, in this incredible redox reaction. I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.